Okay, so in this video we're going to be looking at the pH of salts of weak acids. Let me first remind you that a weak acid is one that partially dissociates. To represent that, we use the equilibrium arrows in the reaction here where you've got your acid reacting with water. So you'll find that in actual fact very few of these ethanoic acid molecules dissociate and produce the ethanoate ions and the hydroniums. Now, taking us to a salt, this here is a salt, and the reason I know that is because it's got the metal cation with the ethanoate anion. So the first equation we write is always the dissociation equation, and salts fully dissociate. So notice that this is a straightforward arrow showing that all of the salt dissociates, which produces the ethanoate and the sodium. Now, you will need to be familiar, and you are familiar, with the fact that ethanoate ions are able to react or hydrolyze with water, and we show that via a second equation. So this is the reaction where the salt of the weak acid now reacts with water. This ion is going to accept a proton and produce the ethanoic acid molecule back, but in doing so you get your hydroxide ions. So I know by looking at this equation that this salt is a basic salt. It produces a basic solution, and the reason I know that is I can see the formation of hydroxide ions. Whenever your hydroxide concentration is higher than the hydroniums, you've got a basic solution. So the take-home message at this point is salts are made up of anions and cations, so you want to be looking at the formula and seeing if you can recognize the metal cation. That will be your telltale sign that you've got a salt. The next take-home message is salts fully dissociate, so your first equation will always be one where you have the straightforward arrow showing full dissociation, and it will break up into the cations and anions. It doesn't matter which order you write those on the product side. Okay, so look for a metal in the formula, because you won't have a metal if it's an acid. You will have a salt if you've got a metal there. So hopefully this makes sense, and you can see that you're always going to have two equations whenever you're dealing with a salt. The first one is the full dissociation of the salt into its ions, and the second one is you select the ion that reacts with water. Now a tip, group 1 cations and group 2 cations, so things such as sodium plus, Mg2 plus, lithium plus, never react with water. It is always going to be the anion that will react with the water and accept the proton, producing the hydroxides, and that's how I know that this is a basic salt. When doing these calculations, you are going to need Kb, because we are doing a weak base calculation. Okay, we've produced a basic salt. So to rearrange or get from Ka to Kb, we use this expression here. However, you might be given the pKa or pKb, so again you're going to need this tool here. Let's run through page 279 in your SciPad. So they've given us the anion, the ethanoate ion, and we already have seen this reaction. And when you see it's producing hydroxide ions, that is your clue you are dealing with a Kb expression, and so it is always the products over the reactants. In this question, they've given us a pKa of 4.76, and we need a Kb value. Now they're asking us to find pKb first, which is easily done. We use this tool here. pKa and pKb is 14. So by subtracting off 4.76, this is just rearranging this equation, so 14 minus the pKa, we get our pKb. We will need the Kb value, so bear with me because there will be more steps. The ratio of ethanoic acid to hydroxide ions is 1:1, which means the concentration of the hydroxides is going to be the same value or concentration of the ethanoic acid. Question 4, they've given us the pH of the solution at 8.89, and we can convert that to the hydroniums by using the inverse log 10 to the minus pH, which gives us our hydroniums. From there we can find our hydroxides using the water dissociation rearranged, which is that answer there. Okay. Question 5 is wanting us to rearrange the Kb expression. Now remember earlier, if you look back at question 3, where we were talking about the 1:1 ratio, I've replaced the ethanoic acid with a hydroxide ion because their concentrations are equal. And that is why it is hydroxide squared and we don't have the ethanoic acid molecule there. I've also made it subject to the ethanoate ion, that's why it's on the left here in Kb. So we've just rearranged this equation. Substituting values in, so we've got our hydroxide values, and that came from question 4, and I haven't shown the steps on how I got my Kb, but that was found from the pKb merely by using the inverse log button. And processing those values in your calculator, you get the concentration of your ethanoate ion, which is what the question was after. So I hope you followed through. I know I went through quite quickly. Question 7 on page 279 is a question where you're looking at sodium methanoate. So again, follow the steps. Always do a full dissociation equation initially, and then the second part is showing the, what are we doing, anion with water, which is where I find that it's the hydroxide ion. These are the steps you need to take. It's not a guided question, so if you need a guide, then follow through these steps. Pause the video because in the next slide I'm going to show you my answer. And here you go. These are the steps shown in the working and the answer to the question. Well, I hope you found that useful, and I'll see you in the next video.